Good morning, children. So, welcome back to the online session of physics class. So, as we have known that we are discussing about circles lesson. So, in that we have completed the lesson and giving the question and answers for the exercises. Okay. Now, till now I had given the answers of the 9th question. I had explained the answers of the 9th question. In today's session, we will go for the 10th question. So, 10th question it will be the numerical problem. So, it is a numerical problem. Whenever they are given the numerical problem, we should understand that what is given, whether they are given the lens or mirror. So first we should understand that whether they are given in the numerical problem, whether they have taken the lens or whether they have taken the mirror. Okay, so that we need to find out that. After that, we should take the physical quantities whatever they are given, that is focal length, object distance, image distance, object height, image height. So these quantities and all we should take it down, and we should take the sign also for these quantities. So we know that according to the Cartesian coordinate system, if it is lying on the positive x-axis, then we should take positive. If it is lying on the negative x-axis, then it is negative. If it is on the positive y-axis, then positive. Y-axis it is negative. So according to the Cartesian coordinate system, sign convention had explained for both mirror as well as the lens. It is same for mirror also, it is same for lens also, but it will be changing for the depends on the lens, whether it is a concave lens or convex lens. Similarly for the mirror also, concave mirror or convex mirror, it will going to change where the focal length will be, where the object is, whether the object will be keeping on the left side, where the image is formed on the left side or image is formed on the right side. If the image is formed on the left side itself, then the image distance will be, it is negative because it is lies on the negative x-axis. If the image is formed on the right side, then that means other side of the lens or mirror, then it will be positive value because it will be formed on the positive x-axis. Okay, if it is inverted, then it is positive because height will be on the positive axis. If it is, what is that? If it is if it is not inverted. If it is real, then it is positive. If it is inverted, then it is negative because it is negative y-axis, right? So depends on the image and depends on the object. So sign is going to change. So that we need to, that will going to change from problem to problem. So we need to understand the numerical problem clearly and we should answer that. Okay, here we need to write ray diagram also. So okay, now we'll understand in this they are given the lens of mirror. Obviously it is a lens. Okay, so this lens, of course it is a converging lens. It is a converging lens. Which is converging lens? Convex lens or concave lens? Convex lens will be the converging lens. Convex lens will be the converging lens. So here is convex lens. They are given the converging lens. An object 5 cm in length. An object 5 cm in length. An object 5 cm in length. What is that? An object 5 cm in length. What is that? That is height. Height of the object. Object height. Height of the object or object height. So given object height. Height of the object. Of object will be denoted by h. How much? 5 cm. We'll discuss about whether it is positive or negative after that. Okay. Now, object height, then in length is held 25 cm away from a converging lens. Suppose I assume that there will be a converging lens, convex lens. Okay. I'll be writing a rough diagram. Because I need to write the diagram. Okay. So it is a converging lens, convex lens. So I'll be writing a rough diagram. So an object is 5 cm in length. It is 5 cm in length. AB. So it should be 5 cm. It should be 5 cm. Length is held at 25 cm away from the lens, converging lens. So object distance is 25 cm. Object distance is 25 centimeter object distance. Object distance will be denoted by u, that is 25 centimeter. You can observe that object will be negative x-axis. Object kept at the negative x-axis, so distance will be at the negative x-axis. So that is what? Negative. So whereas the object height is 5 centimeter, but if you are taking a height, that is y-axis, right? So that is on the positive y-axis. That is on the positive y-axis. Therefore, object height will be positive only. Okay. Now, converging lens of focal length 10 centimeter. Focal length will be denoted by small f. That is 10 centimeter. You can observe that focal length for this, since it is a converging lens, where it will be converged? So I will be having the f to whatever the rays which you take for this, that will be converged here, right? So if you take the rays, that will converge here. So there will be a focal length on the other side of the lens. So therefore it is on the positive what? X-axis. So therefore focal length will be a positive value. Focal length will be a positive value. So you know that I have given that focal length will be positive for converging lens and it will be negative for diverging lens. I have given that, right? Focal length positive and negative. So I have given that focal length will be a positive value for the converging lens and it is negative for the diverging lens. So we have written this. Now focal length. Draw the ray diagram. Draw the diagram. In fact, it is a ray diagram. Draw the ray diagram. Okay. And find the position, size, and nature of the image form. Find the position, nature, and size of the image form. Okay. So using this, we'll find out where is the image form and what is the position and what is the size and what is the nature of the image. We'll see that. Okay. So we'll find out by lens formula. Lens formula we have. What's lens formula? 1 by v minus 1 by u is equal to 1 by f. So using this lens formula, we have given the object distance. We can find out the object distance. If you find out object distance, then we can able to find out the where is that object, whether it's on left side of the mirror or right side of the mirror, same side of the object or other side of the lens. We'll see that. Okay. Now keep 1 by v here only. Okay, send 1 by u to the other side. So 1 by f, we have 1 by f here itself. We send 1 by u to the other side, plus 1 by u, correct? So we'll substitute the values. We'll substitute the values. We'll substitute the values for 1 by u is equal to 1 by focal length. Focal length is 10 centimeter plus 1 by u. U is minus 25 centimeter. Minus 25 centimeter. We'll simplify this and we'll find out the u value. Okay. How to simplify this? 1 by u is equal to 1 by 10 as it is. Okay. Denominator we are having a negative sign, that will be transferred into numerator. Then it will become minus 1. So plus into minus, minus. Right? So 1 by 25. 1 by 25. Okay. So what we will do? We will cross multiply it. What is cross multiply? 25 into 1, 25 minus 10 into 1, 10. The denominator multiply 10 into 25. It is 250. Correct? Okay. So the next step, 1 by u is equal to 25 minus 10, 50. Positive because the higher value between 25 and 10 is 25. 25 before that they are having the positive sign. Denominator they are having 250. Okay. Now, can we able to cancel it? We'll do one thing. This is 1 by u, right? We need u. So we will take reciprocal of this. So this is u by 1. We are taking here also in LHS. We should take on the RHS also. That is 250 by 15. Correct? Now, we'll cancel that. Otherwise, we will divide that directly. Okay. looking on the other side. V we need to find out, that is image distance. We'll divide that by 15. 250 by 15. So 15 ones are 15. So take the remaining. Bring the next digit, that is 0. So how many times will go? 15. 6 are 6 5s are 30. 3 6 1s are 6. 6 plus 3 9. So again we made it with 10. Put the point. Then 0. Again 50. 6 are 90. Again 10, you have put the point already, then 0, 15 6 are 90. Again 10, we skip on going like this. Skip on going like this. So after the decimal point, we will take 2 digits, that is 16.66. So V by 1 is equal to, what is that? So V by 1. V by 1 is nothing but V only. If we divide V by 1, it will be V only. So if you divide 250 by 15, you are getting 16.66 centimeter. This is the V. What is V? 16.66. What is V? V is image distance. And you can observe that you are getting a positive sign. You are getting a positive sign. So where is the image now? Where is the image? Convex lens of object 5 centimeter. This is the object 5 centimeter, and this is length 25 centimeter. 25 centimeter away from the convex lens. Okay. So object distance is 25 centimeter. It is on the negative x-axis. 25 centimeter. That is object distance u is equal to minus 25 centimeter. Correct. But we are getting 16.66, that is positive value. So that means where will be the image? So if it is a positive value, then it has to pass it on this side, right? 16.66. Somewhere else will be the image. So still we need to find out that the image will be a inverted image or real image. Inverted image or real image. That we need to find out whether it is inverted image or real image. The only thing we have got that image will be lies on the other side of the lens. Image will be lies on the other side of the image. From the conclusion, the positive value of V states that image is formed. So we can write image is formed. The positive value of V, positive value of V indicates that image is formed image is formed on the other side of lens, image is formed on the other side of the lens. Still we don't know whether it is a real image or whether it is an inverted image or what? Erect image. Whether it is erect or inverted image. That we need to find out. That we will find out by using the magnification. Whether it is a real image or a virtual image. Real image or virtual image. We know that if it is a real image, then definitely it is inverted. If it is a virtual image, then definitely it is erect. So that real and virtual can be found out by using the magnification concept. Okay, we'll find out the magnification and we will come to know that whether the image is real or virtual. Okay, so magnification, we'll go for magnification now. So magnification m is equal to, so what is given? Here object distance and image distance they are given. We will use that only. So for the lens formula we don't have negative sign. That is directly V by U. It is V by U. We will substitute the values. V is 16.66. U is minus 25. Correct? V is 16.66 and u is 25. Okay, again you will be getting an empty value. We will simplify this. So how to simplify this? Denominator we are having 25, 16.66. We will make denominator 100. Denominator 100. Then it's very easy to divide. If the denominator will be there in 10, 100, 1000. Then it's very easy to divide. Say suppose I'm having 186 divided by 100. How to divide this? So no need to divide by 186 by 100. Since I'm having denominator by default, I'm having decimal point at the last. By default, I'm having decimal point at the last. So dividing by 100, how many zeros? 2 zeros. So bring the decimal point to the left side. How many digits? How many zeros will be there? That much digits we need to bring left side. So 1, 2, this is 1.86. That's it. The same number is divisible by 10. Then again the decimal point will be at the last. How many number zero we have? 1 0. So bring the decimal point left side 1 digit. So 18.6. So if it is 186 divided by 1000, then how many zeros? 3 zeros. Then how many digits we need to bring? Left side 3 digits. 1, 2, 3. That is 0.186. Very easy. So if it is divisible, we have 10, 100, 1000, then it's very easy to divide. So let us bring this denominator into 100. So how to bring that? So 25 into 4 will become 100. So if I want to multiply by 4 over here, then we need to multiply by 4 here also. Then 4 will get cancelled. Our original number will be original number. So our assumption is correct. There is no harm in our assumption. Okay. So now if I want to multiply by 4 denominator, I need to multiply from numerator also. That is 16.66 into 4. We will multiply that 16.66 into 4. So 4 6 are 24. 4 6 are 24. 26. 2 will be remaining. 4 6 are 24. Again 26. 2 will be remaining. 4 1s are 4. 4 plus 2 6. 66 point. So negative sign you will bring into the numerator. Okay. 66.66 divided by 100. Divided by 100. Now you can observe that it is divisible by 100. 2 zeros. So I have a decimal point here. So how many digits I need to shift to the left side? 2 digits because I am having 2 0. 1, 2. So which is minus 0.66. 0.66, which is magnification. Magnification is equal to minus 0.66. Minus 0.66, and you can observe that we are getting negative sign in the magnification. Negative sign in the magnification indicates that the image is what? Real or virtual? Obviously the image is real. The negative sign in the magnification indicates that the image is real and formed behind the mirror. So what is the position, what is the nature, and what is the size? So size we need to define. Apart from position we have defined, nature also we have defined. The only thing is we need to define the size also. Okay. So size we need to define. That we will find out the h dash. That means object height. If you find, image height. If you find out image height, and if you compare with the object height, which is smaller, you can compare that, you will find out that which is smaller, that will be the smaller size, whether it is enlarged or diminished, whatever you can define it. So what is defined now? Position we have defined, nature we have defined. Position we have defined from the V. Where is the position? It is from behind the, not behind the mirror, on the other side of the lens. On the other side of the lens. Okay. Then from the magnification, negative sign indicates that it is a real image. It is a real image. Okay. Then size. We will find out the size by using the magnification formula. For the magnification, we have one more formula. What is that? For the magnification, we have one more formula. What is that? Magnification is equal to magnification M is equal to h dash by h. This is also a magnification formula, right? This is also a magnification formula. So magnification, how much that? Minus 0.66. Correct? H dash. Image height. We don't know. We will write that as it is. H is Object height. What is the object height they are given? They are given 5 centimeter. 5 centimeter. We write 5 centimeter because it's a 5 centimeter object height. Okay. So we find out h dash. So it is divided. If you bring to the other side, it will get multiplied. Correct. So 0.66 into 5 is equal to h dash. So multiply this. 5 6 are 30. 5 6 are 30. 33. So 3. So 5 0 0. Okay. 5 0 0 0 plus 3 will become 3.30. Correct. 3.30. Negative sign as it is equal to h dash, or h dash is equal to minus 3.3 centimeter. So you can observe that image height is 3.3, object height is 5. So image height is 3.3. So you can conclude that it is a diminished image. It is a diminished image. It is a smaller image than the object. It is 3.3. Negative sign indicates that what? Negative sign indicates that. So it is a what? Inverted image. It is an inverted image. Suppose image is formed here. It will be 3.3. So B dash, B dash. So 3.3. So this negative sign indicates that it is on the negative y-axis. It is an inverted image. It is an inverted image. So of course it is a real image. Real image is always inverted. Okay. It is a real image. So real image is always inverted image. Okay. So this indicates that height of the image is minus 3.3. So this indicates that image is diminished. So we have to find the negative sign in the, so for the magnification, whether we have defined that. The negative sign in the magnification indicates that the image is real. Image is real. Okay. So we'll write the ray diagram for this. Now complete ray diagram for this. We'll write that. So how much it is? 5 centimeter. It is like that. Focal length will be 10 centimeter, right? So we'll take for 20. We'll mark it for 40. Initially, we'll write in reference line. Write the reference line. Okay. And that mark it 40 centimeter because focal length they are given 10 centimeter. So 10, 10, 10, 10. So distance between 2f1 and then 2f2 must be 40 because focal length is 10 centimeter. Distance between optical center to principal focus will be 10 centimeter. It has to be equal distance, right? So how many equal distance we have? 4 equal distance we have between 2f1 to 2f2. So 10 plus 10 plus 10 plus 10. How much? 40, right? Mark it for 40. Mark it for 40. So here it is. So here it is. Okay. So this is 2f1. This is 2f2. Okay. Now we'll increase that. Okay. This is the converging lens. We have done that. We'll take half of that. That will be the optical center. 2f1, then 2f2. Exactly 20. This is 20. Again, this is 10. And this is 30. Okay. Now this is optical center. You have 1. You have 2. You can equal to principal focus 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter, 10 centimeter. That you should verify that. Okay. Now, image is kept at what? It's a 5 centimeter image. It is kept at 25 centimeter away from the converging lens. So 25 centimeter from the lens. So 25 centimeter. So image is placed here. Okay. So how much it is? 5 centimeter image. You should mark 5 centimeter length. So this is the image. Okay. This is A, B. Okay. Now we'll write the two standard rays and we'll try to find out the image for this. Right? One ray will be. Okay. Before that, we should write the reference line for this. Okay. We write one ray which is parallel to the principal focus. Principal axis. That will pass us to the principal focus. Okay. This is one incident ray. If it is parallel to the principal axis, that will refract it through the principal focus. So one more standard ray will take, that is through the optical center. Through the optical center, that will not get any diversion. Through the optical center, this is the second ray. Okay. So you can observe that both rays will be intersecting here. So here the image is rotated. A dash, B dash. So you can observe the distance from the optical center. You must get 16 point something. You can observe that 16 point something. It is there 16 point something. So object image distance is 16.6 centimeter, and object distance is 25 centimeter. Okay, its height is 5 centimeter. Object height is 5 centimeter. You can measure the image height also, that is around 3.3. In the numerical problem we got 3.3, right? You can observe from the scale also it is around 3.3 only. Okay. So this is the ray diagram. So this we need to do by using the compass and the scale only. It has to be exactly. Whatever the values will be there, for that exact that values you should write the ray diagrams. So in the which is for today's class, if you have any doubts for today's class, just get back to me. We will continue the lesson in the next class. Okay. So thank you. Practice this ray diagram as well as practice this type of numerical problems, because you will be having one numerical problem from the light lesson. Okay. So practice this. Any doubts? Just get back to me. Thank you.